this is kind of building off those factoring principles, right? So if we look at something kind of the opposite direction of, let's take a look at what this is supposed to be. Alright, so we've got this 5m plus 1, and then this 5m minus 1 that are being multiplied. Okay, this is what your bell work was on basically, right? We all had multiplying binomials. Yes? Okay. So if you struggle with bell work, pay attention, especially right here, because this is what you struggle on. Alright, so you have 5m times 5m, 5 times 5 is 25. Okay, and then m times m is m squared. Alright, 5m times negative 1, well 5 times negative 1 is negative 5. And then you have m. Okay, 5m times 1, 5 times 1 is 5. M times 1 is still m. Okay, and then 1 times negative 1 is negative 1. Alright, so as we look here, we've got this 5m and we've got this negative 5m. Okay, what happens when you have 5 minus 5? It becomes what? 0. 5 minus 5 is 0. Right, so those get canceled out. It's no longer there. Alright, so when we write this, essentially what we have 25m squared plus 5m minus 5m minus 1. Right, that's what we had inside the box. Okay, this 5m minus 5m would eventually cancel. Right, so what we end up with is our final answer is this 25m squared minus 1. Alright, and what we want to notice for these types of problems that we're working today is that when our answer is finalized, like we have on this right side, that everything there is a perfect square. Okay, and when I say the words perfect square, what I mean is that it's a number times itself, right? You have 2 squared, okay? Think about 2 squared. 2 squared is, what is the multiplication that happens here? 2 squared is what? 2 times 2, right? This is 2 times 2 and you get 4, right? So 2 squared is equal to 4. 2 times 2 is equal to 4, all right? 5 times 5 is 25, okay? M times M is M squared. 1 times 1 is 1. Okay, so all of these individual parts of what's on this right side of our answer is a perfect square. Okay, so we're trying to figure out how do we get today, how do we get from what we have here back to, I'm sorry, I wrote this in the wrong blank. Okay, what do we have here to what did we start with? Okay, that's what we're trying to do today. Okay, this is called the difference of squares. Okay, the reason that this makes sense and why it's called this, obviously number one, everything's a perfect square. Okay, that's where the squares part comes from, difference of squares. Okay, then difference is the second part, or really the first, but another part of it. Okay, difference means to do what in math? Subtract. What do we have in between our two terms? The minus sign, which would be subtraction, right? So that's what we're looking for. We're looking for perfect squares. We're looking for subtraction today to be able to factor into something like what we have here. Okay, so we want to make sure that we do have difference of squares where we have a perfect square and then a subtraction sign. Okay, if we have it, like what we have here, okay, perfect square minus a perfect square. If that's what we have, okay, then our factors would be something like a plus b, a minus b, and it will be that every single time. Okay, if we have a difference of squares problem, your answer would look like this every single time, where you have the same thing here for a, these two would be the same, b would be the same, and one binomial has a plus, one binomial has a minus. Okay, and you'll see this over and over again with what we're doing today. Okay, so we have to be thinking about on number one, do I have a perfect square? Okay, yes, a squared is a perfect square. A squared is a times a. Okay, 4 is a perfect square. We just talked about that above, right? 4 is 2 squared. Okay, now, how do we figure out if we have a perfect square? If I don't know my perfect squares, how do I figure it out? Okay, on your calculator, probably look with me, okay? On the left side, okay, you need to press second, that's your blue button. Do you not have the calculator? Alright, pressing second on the calculator So that's your blue button, and then there's the button X squared, okay, on that left side. So when you press second X squared, it should pull up the square root. Okay, you should have the square root that's pulled up now. Now in that square root, put 4. So second X squared, and then under the square root, put 4, press enter. What do you get? 2. Okay, so that tells us that that's a perfect square of 2. Now do the same thing again, okay? Do the same thing again. Do second X squared, and then put 5 under the square root. So second X squared, and put 5 under the square root. What do you get this time? 2 point something, 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 something. Okay, that's not a whole number. So since that's not a whole number, that tells you that that is not a perfect square. Okay, 4 was a perfect square, but 5 was not. Okay, that's how we're going to check. Okay, and we know already, just based off what we've been doing, multiplying, right? If I multiplied this, and I had, A and A here, y'all would tell me A times A is A squared. Okay, so A squared is a perfect square, A times A, right? So we do have our perfect squares, and we have the minus sign. So we want to set up 2 binomials, just like this. Okay, this will be your answer. So you're setting up 2 binomials, or 2 parentheses that will be binomials. You'll put a plus sign in the middle for one, and a minus sign in the middle for the other. Every time. Okay? Now, I'm taking the square root of either of these. So what makes x squared? We've been talking about it. What makes x squared? A times A. We've been talking about that. What makes 4? You take the square root of 4, it's 2 squared, so 2 times 2. And now you have your answer. So that's how you do difference of squares. It'd be like that every single time if you have a perfect square minus a perfect square. Okay? Alright, so let's look at another one. Okay, we want to see, is 81 a perfect square? So you're going to do second x squared and then put 81 under the square root. What? It is, right? What's that number that comes out? 9. Right? 9 times 9 is a perfect square. X times x gives me x squared, right? So we know that's a perfect square. Okay, so here we're going to have a plus, we're going to have a minus. So the square root of 81 is 9. Kind of looks like A there, but that's 9 and 9, alright? And then what's the square root of x squared? That's x, okay, because x times x is x squared. Alright? Feel okay about that? Alright. So let's look at 5, okay? Is k squared a perfect square? Yes, right? K times k. Alright? Is 25 a perfect square? Yes. Right? What's the issue with number 5? Say again. Well, they are both perfect squares, so that's not the issue. What's the problem with number 5? The plus, right? We're talking about difference of squares. So this would have to be a minus sign like we have on 1 and 3. Okay, with this being a plus, we can't factor this. Okay, this is not factorable. What do we call it when you cannot factor? Prime. This one's prime. Can't factor that one. And the reason we can't factor that one is because of the plus sign that makes the problem wrong. So we can't do it. There's no way to factor that. Alright, any questions on 1, 3, or 5? Alright. So on 7, 7 throws in a coefficient in front of our variable. Okay, so we have to check that too. Okay, so we want to check, is 9 a perfect square? Okay, so you're doing second x squared 9. Okay, is that a perfect square? Yes, what is it? 3. Okay, b squared is a perfect square. We know that's b times b. Okay, so that's the perfect square. Is 100 a perfect square? Yes, what is that? 10, right? So here we're going to have our 2 parentheses. We're going to have 1 plus, 1 minus. Okay, the square root of 9, y'all told me was 3. The square root of b squared is b. So we got 3b and 3b. All right, then we got 100. The square root of that, y'all told me was 10. Okay, so we got 3b plus 10, 3b minus 10. All right, any questions there? All right, so let's check out number 9. Okay, 16, is 16 a perfect square? Yes. Okay, what is it a perfect square of? 4. A squared, is that a perfect square? Yes. Okay, and then 121, is that a perfect square? What is that a perfect square of? 11. Okay, so we know that we have perfect squares and we have the minus sign in the middle, so we're good to factor it. You're gonna have a plus, have a minus. Square root of 16, y'all told me was 4. Square root of a squared is 8, so 4a and 4a. Okay, square root of 121, y'all said was 11, so we're gonna put 11. All right, any questions on number 9? All right. So, is 4 a perfect square? 4 is a perfect square of what? 2. Okay, is h squared a perfect square? Yes, it's a perfect square of what? H. Okay, is 25 a perfect square? Yes, a perfect square of what? 5. Okay, I know there's not 2 people that can just put the in the calculator. I know there's more than 2 people. All right, is g squared a perfect square? Yes, g squared is the perfect square of g. Okay, so since we have all these perfect squares and we have the minus sign, we'll do our plus, our minus. Okay, y'all told me the square root of 4 is 2. Square root of h squared is h. We got 2h, 2h. Okay, square root of 25 is 5. Square root of g squared is g. So you got 5g and 5g. All right. Any questions on 11? Y'all feel better or worse about this compared to greatest common factor? You like this more or less? You like this more? Some people don't like it. Okay. About the same. All right. Let's move on to this next page. Actually, that's it for today. Y'all want to work some more problems on that? Everybody feel somewhat comfortable. Kind of a quick one. It's going to leave you with a lot of time to get Khan Academy done. Y'all would rather that. Y'all don't feel good about it. We need to do more problems. I've just got blank stares. What do you think? Feel good? Need to work on Khan Academy or more of these? All right, give me a second. I'll have those assigned, and then you.